filled 2 identical glasses with water, one boiling, one cold. Put them both in the freezer. Which one freezes first? If you said the cold one, you might be wrong. Under certain conditions, the hot water freezes first, not slightly faster, sometimes exponentially faster. This violates everything you think you know about heat and cold. It seems impossible, and yet Aristotle noticed it 2,300 years ago. Francis Bacon wrote about it. Descartes described it, and then everyone forgot. Until 1963, when a 13-year-old boy from Tanzania noticed it while making ice cream, his teacher laughed at him. His classmates mocked him for years. He was right. They were wrong. This is the Mpemba effect. And after 60 years, science still can't fully explain it. Tanzania, 190-63. Magamba Secondary School. Cookery class. The assignment was simple. Make ice cream. Boil milk with sugar. Let it cool. Pour it into a tray. Put it in the freezer. A boy named Erasto Mpemba was running late. His classmate had already mixed his milk and poured it straight into a tray without boiling. Mpemba had boiled his, but there was only one ice tray left, so he skipped the cooling step and poured his boiling mixture straight in. An hour and a half later, Mpemba's tray had frozen into ice cream. His classmate's, the one that started cold, was still a thick liquid. Mpemba was confused. He asked his teacher, why did the hot mixture freeze first? The teacher's answer, all I can say is that is Mpemba's physics and not the universal physics. The classroom erupted. It became a running joke. Every time Mpemba made any mistake in class, someone would say, that's Mpemba's physics. He transferred to a new school, Mkwawa High School. He asked the same question to a new teacher. The answer, you are confused. This cannot happen. But Mpemba didn't stop asking. He repeated the experiment. Hot water, cold water, same containers, same freezer. Again and again. The hot water kept freezing first. Everyone told him he was wrong. He kept testing anyway. One day, a physicist named Dennis Osborne visited Mkwawa High School to give a lecture. Osborne was a professor at the University College of Dar es Salaam. After the talk, Mpemba raised his hand. In front of his teachers, in front of all his classmates. If you take 2 beakers with equal volumes of water, one at 35 degrees and the other at 100 degrees, and put them into a refrigerator, the one that started at 100 degrees, and put them into a refrigerator, the one that started at 100 degrees, freezes first. Why? The room erupted again. Teachers laughed. Students laughed. But Osborne didn't laugh. He didn't have an answer either. But he didn't dismiss the question. He invited Mpemba to the university. They set up the experiment together, carefully, controlled conditions. The hot water froze first. Osborne assigned his technician to repeat the tests. Same result. Osborne later said, but it is true. The hot water does freeze first. In 190-69, they published a paper together, a 13-year-old's question, answered 6 years later. The paper was titled, simply, Cool, a schoolboy, co-authoring a physics paper, with a university professor. If this story resonates with you, subscribe, because the science behind it is even more surprising. Here's the twist. Mpemba wasn't the first to notice this. He wasn't even close. Around 350 BCE, Aristotle wrote in Meteorologica that hot water freezes faster than cold. Over 2,000 years ago, he explained it through antiperistasis, the idea that a quality intensifies when surrounded by its opposite. In 1461, an Italian physician named Giovanni Marliani tested it. 4 ounces of boiling water, 4 ounces of cold, same containers, outside on a winter day. The hot water froze first. He couldn't explain why, in Fultwischer, because lateral printrate, its experience shows that water kept on the fire freezes sooner than other water. In 1775, Scottish scientist Joseph Black confirmed it with controlled experiments, even accounting for evaporation. 5 great thinkers, 23 centuries, and every single time, the observation was made, and then forgotten, because it seemed to contradict the basic laws of thermodynamics. Mpemba didn't discover something new. He rediscovered something. So why does it happen? After 60 years of research, scientists have proposed at least 5 explanations. None of them alone is complete. First, evaporation. Hot water evaporates more. Less water remains. Less mass means faster freezing. Simple. But the effect has been observed even in sealed containers where no water escapes. Second, convection. Hot water creates stronger temperature gradients against the container walls. Bigger gradient means more vigorous convection. The water circulates faster, moving heat to the surface more efficiently. Third, dissolved gases. Cold water holds more dissolved oxygen, CO2, and nitrogen. Heating drives these out. Water without dissolved gases behaves differently. It may conduct heat better and crystallize more easily. Fourth, supercooling. This might be the most important. Water can cool below 0 without freezing. It stays liquid in a supercooled state. Cold water is more likely to supercool. Hot water, having lost its dissolved gases, nucleates ice crystals more readily at 0 degrees. So hot water starts freezing sooner. Fifth, hydrogen bond memory. A 2013 study proposed that heating water strengthens certain hydrogen bonds. These stronger bonds create small clusters that serve as templates for ice crystal formation when the water cools rapidly. The catch? Computer simulations have reproduced the Mpemba effect even without these mechanisms. And the effect appears in substances that aren't water at all. Polymers, magnetic alloys, colloidal systems. It might not be about water. It might be about how far from equilibrium you start. In 2016, 2 scientists tried to kill the Mpemba effect. Henry Burridge and Paul Linden published a paper in Nature Scientific Reports questioning the Mpemba effect. Hot water does not cool more quickly than cold. Carefully controlled experiments. Their conclusion: there is no evidence for the Mpemba effect. 60 years of observations? Poor experimental design. But other scientists pushed back. James Brownridge at Binghamton University argued the study was flawed. Burridge and Linden measured cooling to 0 degrees, not actual freezing. The phase transition matters. Other researchers agreed. The definition of freezing changes everything. Then came 2020. Avinash Kumar and John Beckhofer at Simon Fraser University published in Nature. They used tiny glass beads in water, controlled by optical tweezers. Precision that earlier experiments couldn't achieve. The result: under certain conditions, hotter objects cooled exponentially faster. Not slightly, not marginally, exponentially. The hotter beads cooled in 2 milliseconds. The cooler beads took 10 times as long. The strong Mpemba effect. Demonstrated. Controlled. Reproducible. A schoolboy's observation from 1963 confirmed in a physics lab in 2020. And then it went quantum. In 2024, physicists discovered the Mpemba effect in quantum systems. A trapped ion, far from equilibrium, returned to its symmetric state faster than one that started closer to equilibrium. The quantum Mpemba effect, published in Nature Communications, 2025. Multiple research groups worldwide confirmed it. The explanation connects to non-Hermitian physics and exceptional points, deep, strange corners of quantum mechanics, starting from a more extreme state. Opens up shortcuts through the energy landscape that simply don't exist for states closer to equilibrium. What started as a boy making ice cream in Tanzania is now one of the most actively researched topics in non-equilibrium quantum physics. From boiling milk to trapped ions, from a school kitchen to nature, 60 years. From ridicule to the quantum frontier. Erasto Mpemba died on May 14, 2023. He was 73. He'd spent his career not in physics, but in wildlife conservation, as a game officer for the Tanzanian government. He never became a physicist. He never studied thermodynamics formally. He noticed something, he asked a question, he was laughed at, and he kept asking. Think about that. A 13-year-old in a country with limited access to electricity noticed something that Aristotle, Bacon, and Descartes had all noticed, and that the entire scientific establishment had dismissed for over 2,000 years. And his teacher told him, that is Mpemba's physics, not universal physics. It turned out to be universal physics. I think about the questions I've stopped asking because someone told me they were wrong. The observations I've dismissed because they didn't fit what I already believed. The times I've been the teacher, so certain of what I knew, that I couldn't hear what was right in front of me. Mpemba didn't have a degree. He didn't have credentials. He had a question and the stubbornness to keep asking it. Sometimes the most important discovery isn't the answer. It's refusing to stop asking the question. Erasto Mpemba asked a question in 1963. Science still hasn't fully answered it, but the question changed physics. From classical thermodynamics to quantum mechanics. From a school kitchen in Tanzania to labs on every continent. Hot water can freeze faster than cold. It shouldn't, but it does. Next week, the scientist whose cells are still alive. 60 years after she died, nobody asked her permission. The story of Henrietta Lacks, 163. His teacher laughed. He was right. 34 chars. 4. The ice cream that broke physics. 32 chars. 5. Why hot water freezes faster. And nobody believes it. 52 chars.